Given a positive integer array and an integer k. The score of a subarray is sometimes its length. Count every non-empty contiguous subarray whose score is strictly less than k, return that count. Example 1 with k equal to 10. Subarray 2 alone scores 2. Window 0 to 1 scores 6. 1 alone at index 1 scores 1. 4 alone scores 4. 3 alone scores 3. 5 alone scores 5. Subarray 1-4 would score 10, so it does not qualify. 6 subarrays qualify in total. Example 2 with k equal to 5. Each single one scores 1. Each pair scores 2 times 2, which is 4. The full triple scores 9, so it fails the strict bound. 5 subarrays qualify. Before sliding any boundaries, a beginner must understand exactly how a Windows score is calculated. The score isn't just the sum of the numbers, it's the sum multiplied by how many numbers are inside. For our very first element, a single 2, our sum is 2, our length is 1, and our score is 2. Because 2 is strictly less than 10, this single element window is perfectly legal. As our right pointer advances to index 1, our window stretches to enclose both the 2 and the 1. This expansion pushes our sum up to 3 and our length up to 2. Multiplying them gives us a total score of 6. Since 6 is still under our threshold of 10, our expanded window remains safe. Here is a crucial trick for counting combinations. Every time our right pointer moves to a new slot and the window is valid, it introduces a whole family of valid subarrays ending right there. Because our entire window has a score less than 10, any smaller subsection inside it sharing that right edge is mathematically guaranteed to have a smaller sum and a smaller length, meaning its score will also easily be less than 10. The number of these valid subarrays is exactly equal to the window's current width, right minus left plus 1. We add 2 to our total count. Now, we hit the breaking point. Our right pointer takes another step, absorbing the 4 into our frame. Our sum grows to 7 and our length increases to 3, causing our score to skyrocket to 21. We have broken our ceiling of 10. Because every number in this array is positive, expanding further right will only make the score larger. This window is broken permanently, and we cannot harvest any combinations yet. To repair the breach, our left pointer must contract the window. As the left pointer moves forward, it subtracts elements from our running sum while shrinking our length at the exact same time. This double reduction rapidly drops our score. We slide the left pointer forward until our score falls back under 10, stabilizing our window down to a single element, the 4. Now that our window is back in a safe state, we run our width check one last time. The window's width is 1, meaning it contributes exactly one new valid subarray ending at this position, the number 4 by itself. We add it to our vault, completing our single forward sweep across the array to find a grand total of 3 valid subarrays. We kick off our solution engine by establishing our pointer coordinates. Both our tracking boundaries, left and right, pin themselves directly to index 0 at the very beginning of our line. We set our baseline window sum and our cumulative combination tracker cleanly to 0. We launch our outer loop, advancing our right pointer forward to absorb new values into our window frame. As the right pointer captures the 1 at index 1, our window sum updates to 3, while our length expands to 2. Multiplying these factors gives us a real-time window score of 6. Because our score of 6 sits safely beneath our target threshold of 10, this entire window layout is completely legal. That means any smaller subarray packed inside it that shares this same right edge is mathematically guaranteed to be legal too. We capture this entire batch instantly by reading the window's width, depositing 2 new valid configurations into our vault. Next, our right pointer takes another step forward, capturing the 4 at index 2. This push swells our window sum to 7 and drags our length out to 3, causing our score to spike to 21. We have broken through our target ceiling. Because we are dealing exclusively with positive integers, expanding further is completely broken. To pull our system back into compliance, our left pointer executes a series of strategic evictions. Moving the left pointer forward strips elements out of our running sum while shrinking our window length at the exact same time. This double reduction drops our score, and we step the left boundary forward until the score falls back under 10. With our window back in a completely safe state, we run our final width collection step. At this terminal position, our width is 1, introducing our last valid configuration, the standalone 4. We drop it into our vault, successfully concluding our single linear sweep across the track with a grand total of 3 valid subarrays. N is the length of nums and k is the score limit. Time is O of n, each index enters and leaves the window at most once. Space is O of 1, we only keep the running sum, the left pointer, and the running count. Count subarrays whose score, sum times length, is strictly less than k. Initialize left at 0, running sum at 0, and the answer at 0. Expand right across the array. Add the new rightmost value to the running sum. While the window score is still too large, subtract the leftmost value from the sum. And advance left by 1. Every valid subarray ending here contributes its window width to the total. Return the count of valid subarrays.